Hello, everybody. Welcome to Lunch and Learn. I'm your host, Vince Marino, and this is my Lunch and Learn. And today I've got a great couple of guys with me, Joel and Alan with Grundfos. And I'm going to start with Joel. Joel, can you introduce yourself? Tell us a little about yourself.
Yeah, sure, sure, Vince. Been with Grundfos now going on 4 years. My role within the organization is a field sales manager. That carries both a sales aspect of the role and also a technical support role in the field with the partners and contractors that we deal with. Have a total of 17 years in the business, and that primarily consists of pumping equipment and motors in the groundwater markets.
Excellent. Alan, how about yourself?
Yeah, thanks, Vince. My name's Alan Bixler. I've been with Grundfos for 17 years now, in a number of different roles. I started out as an applications engineer. That's really where I learned the business, answering the phones, having to help select pumps, troubleshoot pumps. It was kind of baptism by fire hose at that time. And then I moved into the product management department as a product specialist for some of our groundwater products. Few years after that, I got an opportunity to move to the outside and took a technical sales manager role for the southeastern part of the U.S. And currently, I'm in a field sales manager role, like what Joel does here in Florida and Georgia. And like Joel said, it's a technical role and a sales role combined in the field.
Got it. I've got you. I love it. And today we're going to talk about a particular part of the pump world, if I'm not mistaken, right? So let's just kind of launch into that. But I do want to ask you this. Isn't Grundfos, am I saying that right? Grundfos, the
Grundfos,
largest, yeah, aren't they the largest manufacturer of pumps in the world? Do I have that right?
that is correct. With the entire portfolio that Grundfos offers, everything from the little red circulator pumps that people may have in their home for heating or hot water recirculation, to the groundwater and irrigation pumps, which is what Joel and I work with, through municipal wastewater, municipal intake, dosing and disinfection for industrial and municipal applications. So Grundfos has a very, very large portfolio. Company started in 1945 in Bjerringbro, Denmark.
Yes.
Paul Du Jensen, our founder, had a machine shop in his basement. He was working as a machinist, and at that time, with the war, products weren't available for people to purchase, and so a farmer came to him and asked him if he could develop some sort of a pump to help him water his livestock. And so he built the first pump in his basement, and it just kind of expanded from there, from a machine shop to actually a pump manufacturer, and now to the world's largest pump manufacturer.
Yeah, and let me explain why I'm wearing my Empowering Pump shirt right now, because this is part of the my excitement about this is I was recently at an event. I'm going to pop that up on the screen real quick. I was at the EFOT show, which is kind of the European version of WEFTEC. It's a big wastewater show. And there's your pumps were part of the operations challenge there. And I got to tell you, our team at the operations challenge did very, very well. Anyway, I just wanted to just kind of flash these fancy shirts that I happened to be wearing while at the operations challenge. And it was really kind of cool to see your pumps as part of the equation there in
Yeah, that's fantastic.
in Munich, Germany. Yeah, just a few months ago. But anyway, so let's go ahead and jump into the SQ slash SQE. Do I have that right?
Yeah, you sure do. The In the submersible pump industry, the which is what Joel and I deal with a lot. And these are pumps for residential water, residential irrigation, and small water intake type of systems. But Grundfos came out with this 3-inch pump technology actually in the 90s. was the first iteration of this, where one of our engineers came up with a micro frequency converter, and they built that into the original 3-inch pump, which was called the Jet Sub. And then in 1999, that morphed into what we have now as the SQ family of 3-inch submersible pumps. Joe, you want to tell them a little bit about the technology?
Yeah, one thing I was going to say, it's interesting because, you know, that piece we just had up on the screen, it says 25 years of proven performance. Like Alan said, this pump was more or less hit the market in the late 90s. And oddly enough, it is the most advanced product in the groundwater market when it comes to, you know, the smaller horsepower submersible range. And it being the most advanced technology, now being 25 years old, I still think that's pretty interesting that this product has, you know, been able to maintain and really not be copied, not be emulated. Because I mean, you know, this thing's been on the market for a long time. But yeah, so the SQ SQE range is really our go-to in the groundwater market for Grundfos in North America and all around the world for residential applications and light commercial applications. You know, for irrigation, for home use, environmental sampling. The pump really was designed as a well saver. And what that means in our world is if you have an old well, 4-inch well with a lot of growth in it, a lot of iron buildup over time or scale, specifically on steel cased wells, if you could get the old 4-inch pump out, if you're lucky enough to get that out, you didn't want to run the risk of trying to get that same size diameter pump back down hole. So this pump originally was designed to be able to save a well. So you didn't have to scrap that 4-inch well, go drill a new one. You could use the SQ, which has a 2.95-inch OD diameter, and easily get that pump back down the old crusted well and save that well. That's really where it kind of got a foothold in my mind in North America. Alan, I think you'll agree to that.
Yeah, I got a funny story about that, Joel. I had a customer one time call me, and they had brought up that their SQ pump wasn't working. It was a new install. They had removed an old 4-inch pump, had a hard time getting it out, put a 3-inch SQ in, and the SQ pump has built-in protection. It's got a dry run functionality, and so every time they would start the pump up and it would start to move water to pump the well off, it would stop. And they thought there was something wrong with the pump. So they pulled it out and they installed another SQ in there thinking that the first one wasn't working properly. Customer called me back. He said, it's doing the same thing. So we started going through a few discussions about what was going on. And he said, well, the 4-inch pump was stuck. And my guys dumped a bottle of Dawn dishwashing liquid down the well to help lubricate it to slide the pump out. So now every time they tried to start up the pump, the water was foaming, and the foam inside of the pump was mimicking dry run because the dry run functionality is based on the wattage that the motor's pulling. And so it was basically vapor locking every time they tried to start it from the Dawn dishwashing. And we had a good laugh about that. And since that time, he has taken all Dawn dish soap out of all service trucks in this company so that it can't happen again.
Wow, that's interesting. Now, how the heck did they get it out eventually? I mean, you got to get that out of there eventually, right? I mean,
yeah, they had to let it settle down and pump it off a little bit at a time until they got enough of the soap out that the pump would stay running.
I'll be darned.
Yeah,
Yeah, let me look at that again. I want to put this back up on the screen and just kind of get an idea. So, all right, I see that it's got the unique 3-inch as a or 2.91 diameter.
Yeah, there's a lot of really cool features. Another one, the 3-inch, obviously, from an installation standpoint, but the widest voltage range. This pump will actually operate the 230 volt version. It'll continue to run all the way down to 150 volts. If it drops below 150 volts, it turns itself off, unlike a traditional pump that continues to try and run and pull current and build heat. It's got a soft start functionality built into it because it is actually operated by a VFD. And that also allows us to put the built-in motor protection in there. And we can show you a cutaway of that in a second on a different slide.
Sure.
But those are kind of some of the functions and features. It's a permanent magnet motor with a micro frequency converter built into it. It's the motor itself is actually a 3-phase motor. So it's taking that single phase 115 or 230 volt input, depending on the motor size, into the inverter. It's being converted just like any other VFD, and then pulsed out as a 3-phase output wave in order to run the pump. The little pump, one of the ways we get the flow and the pressure out of this tiny pump is that it runs at very high speed. Most asynchronous motors, you're talking about 3450, 3470 RPMs. The Grundfos SQ runs at 10,700 RPMs. So it's if you start it up in a tank, when it's in a well, you can't really hear it. But if you start it up in a tank, it sounds a little bit like a jet engine starting up when it first starts going.
That's amazing. And it's got a built-in VFD enclosed in the whole unit. There's a VFD in there.
Yes, sir. In the motor itself. If you want to pull up slide number 2 there that we've got.
Joe, hold that back up again. Let me see. Is that?
Oh, there you go.
Is that a?
So this section here's the whole pump. I don't know if you probably won't be able to see it here, but this section of the pump here is actually where your VFD is housed, which is the bottom third, if you will, of the pump. And then as you move,
right
there we go. As you move up the pump, there's your and if you have familiarity with a 4-inch motor, this is the motor in our 3-inch pump here.
Yeah.
And you can see how very small
it
this permanent magnet motor is. Yeah. And then moving on up, you got the hydraulic stack. So these are actually our impellers. Alan, I would say they're about the size of a 50-cent piece, if anybody knows what that is these days.
Yeah, or so. Silver dollar. Silver dollar, about 2.5 inches.
Yeah, and this is the rotating stack that we have that Alan's talking about that actually turns at 10,700 RPMs, and that's how we're able to get.
And there's three. So I'm sorry, I didn't mean three impellers.
It actually depends on the model. So it depends on where you're at in the range. You'll have more impellers for higher pressure pumps or less impellers for lower head producers. But that 10,700 RPMs out of that very tiny impeller is how we get, the production out of these units. And
what is the head on one of those? I mean, on average,
it can go up to 500 feet on the low flow versions.
That is amazing.
So we've got pumps that within the 3-inch pump range, the SQ and SQE. There's a 5 gallon per minute line, 10 gallon per minute, 15, 22, and 30 gallon. So obviously on the lower flow pumps, we can build higher head. The range of these pumps is from 0.5 horsepower to 1.5 horsepower. So 1.5 horsepower is kind of the max of where we're at right now with this design. And that limits us a little bit in what we can do with the portfolio because we're limited in horsepower. But as you can see from what Joel was showing there, with the VFD and the permanent magnet motor, the electronic controls, and the way that stack is built, this technology was way ahead of its time. It was an extremely innovative product in 1999 when it was produced. Our engineers, hats off to our engineers at the time, and our CEO at the time, Niels de Jensen, who was the son of the founder. He's the one that drove that and pushed engineering to give us this product. And so here you can see a better shot of the cutaway, a little more clear, where on the left-hand side on the screen here, we've got the micro frequency converter. Basically, that's a miniaturized VFD. one of the advantages of having the VFD in the motor where it's at, Vince, is it's in the water. It's down the well, it's in the water. And we all know that the largest enemy of electronics is heat, right?
Yeah. Yeah.
So now we've got that inverter in cool water. We don't have to worry about having airflow and fans and things to redistribute that heat and take it away. And then in the middle section there, we've got the permanent magnet motor. That's really part of the magic in and of itself. We don't have inrush current like we would on a traditional induction squirrel cage rotor. They're permanently magnetized, much more efficient. In the lower right-hand corner here, I've got a little graph that shows general efficiency of a conventional 4-inch single-phase motor, a conventional 4-inch 3-phase motor, and then you see the Grundfos SQ is well above that in overall efficiency of the motor. So not only is it able to go into smaller wells or damaged wells, crusted wells, things like that, but it's also highly efficient, and it's an energy saving device. Now,
Correct.
In a residential application, are we really going to see a significant change in the electric bill at your house going from one to the other? Not really, because the well pumps we use in our homes aren't run for enough hours per day to really see, dollars and cents. You're going to see you may see a 50-cent, $1.50 savings using a pump like this over the other in energy costs. But looking at the scope of things, the more of these pumps we can get out, the more energy efficiency there is, the more we're taking off the grid and being more sustainable with this kind of a product.
Well, that is super cool. I'm glad you guys explained it. And Joel, I got to tell you, I'm glad you held the thing up too. There's nothing like, hands-on showing what it. I mean, it's fair. It's a fairly big size as far as its length. More than I thought, but it's tiny, 3 inches in circumference.
One interesting thing that you can't tell, obviously, with me holding it up here on camera, is from an install perspective. And Alan obviously has been around the product a lot. He can attest to this. When you compare it to a 4-inch conventional and the 3-inch product, from an install perspective, the 3-inch pump is so much lighter. Alan, I would say in some instances, probably 30-40% lighter than a 4-inch conventional.
Possibly more than that when you're talking about, a 1.5 horsepower, high head, low flow pump. I mean, you could be talking about replacing a pump that weighs 45 pounds with a pump that weighs 15.
Yeah, correct.
Wow.
Like down in Alan's area, obviously Alan is out of Jacksonville, and contractors down in Central Florida, they could actually go out potentially and pull this product by hand versus having a pull truck over the hole or additional equipment to take the pump out or install the pump. So I think that's a feature we don't talk about a lot, but lightweight and easy to handle for the installer is something that I think our customers find very important.
Absolutely. There's no doubt about that. My mind is swirling with all kinds of questions here. I want to understand more about just the overall when you're replacing an existing pump. Is it generic to have a 4-inch pump? I mean, it could be brand X or Y. Is that what I'm understanding? It could be some other brand with the 4-inch hole, right?
Yeah.
So,
In the residential pump market, the standard is a 4-inch pump.
okay.
It always has been since those submersible pumps were developed. The 4-inch kind of became the standard in the pump range from 5 gallons a minute up to 75 gallons a minute. That span. 4-inch, and in a lot of areas, the well drillers were installing 4-inch well casing. So a 4-inch pump is just small enough to fit inside of a 4-inch well casing.
Okay,
Some
so
installers.
let me
Go ahead.
I recall, and it was in South Alabama. There was a problem where, and again, we're getting in the weeds here, but what the heck, right? I mean, it's just us
Well, Joel and I
talking.
are both sitting in the weeds.
We're
Yeah.
sitting in the weeds. Yeah.
I love it. You guys are great. I remember seeing a disc-like device that would actually have like spider out supports to support a shaft. Okay, so this was a stabilizer within the hole, down the hole. So there was, I guess, a series of these.
Yeah.
So my question is, if you got a 4-inch hole, and you've got these, what am I calling them? Like a
I think
stable.
stabilizers is probably the right thing. Yeah. I mean, they're basically
Right.
there to stabilize the pipe in the well.
Right. So in my head, I'm thinking, if you have those down there, does that present a problem in pulling it out and dropping one of these 3-inchers down there, one of these SQEs? Is that an issue, or how do you get those out of there? I mean, you know, have you ever encountered that?
Those would pull when they remove the pipe and the previous pump that was in there. Those stabilizers would pull. One of the things you might have seen that may have actually been a line shaft turbine, where there was
Yes.
actually a shaft going down that turned the impellers in the pump that was below it. Kind of
Yes.
a different animal, where you've got a motor up top, you've got a shaft going down that runs the pump. Then you do have those centering stabilizers to hold the shaft in place. The water actually flows up through those and then discharges. So that all comes out in one piece
Yeah,
Okay,
when
that's
you
correct.
what I
remove the
want to.
line shaft turbine.
All right, perfect. So then if you pull that out, and I don't know how many feet down that is, but you pull all that out, then you just drop one of these down in there. Problem
Right,
solved. Amazing.
right, right.
How convenient. 15, 20 pounds weighs.
Yep. The heaviest one I think is about 15.5 pounds.
Yeah. Super
Wow.
light.
Wow. Amazing. All right. So let me ask
So
you
just
this.
from an installer standpoint, the guys that are actually working in the field, the service technicians or installers that are on the truck, think about it from a human standpoint. Now those guys can pick up that pump and carry it from their service truck to the well without um, without straining themselves. Where before, especially in a larger size with a 30-gallon per minute pump or 25-gallon per
Yes.
minute pump, you could be talking about carrying a 40 or 50-pound pump over to the well
Mhm.
site. So there's a physical strain on the people as well.
Joel, you were holding up. Is that the same unit, or is that something
Yeah,
else?
it's the same unit. I was just basically saying I mean, 15 pounds, it's a one-handed carry. Yeah,
Yeah.
super light.
For sure.
So yeah, and I'm trying to imagine if you have an old pump. I mean, how long do these things last down there, right? So you have to get the old one out. I imagine you have to have some kind of a tripod above it, and you're kind of pulling
Uh,
it out, or how
yeah,
does that?
depending on what you're pulling out. I mean, sometimes a crane truck is required. Believe it or not, even for 2, 3, and 5 horsepower types of pumps that are deep sets on steel pipe, steel drop pipe. Um, but in most instances with the SQ or the SQE, most of that stuff is set on rolled poly pipe or PVC, and it can be pushed and pulled, as we call it. It can be installed by hand. Um, I would say the majority of them are, at least in a lot of the areas that Alan and I cover, unless you
Yeah,
get over into the mountains or something where you got some really deep sets. But um,
interesting.
yeah, you got
So,
a lot better likelihood with that pump from an installer perspective. It's very, very friendly, I guess is the takeaway.
So
um,
Vince, I want to circle back real quick. We started this conversation talking about the Grundfos SQ SQE. There's actually a line there for a reason. The SQ version of this pump is a fixed speed. It operates with a pressure switch. It's either on or off, and it provides a pressure up to the set point of the pressure switch, and then it turns off. The SQE version of this is actually electronically controlled. Since we do have a VFD in the motor, with the SQE, we have the ability to communicate with that VFD from a box above ground connected to a pressure transducer, and actually have a constant pressure system where the motor can speed up or slow down to maintain a constant set pressure independent of the flow. And so that's the difference between what we call SQ and SQE. The SQE is a variable speed constant pressure side of this, which gives the homeowner as close to city water like pressure and flow as you can get with a well pump.
Correct.
So let's talk about the, obviously these devices are equipped with some kind of cabling system that you're lowering it down in there with, like, a power supply, wiring, if you will. So take me down that. How does that work? I mean, I'm assuming these are heavy duty cables that are water resistant and that kind of thing. Can you talk me through that? I'm the layman. I don't know these things, so I'm just asking.
Yeah, so a typical install is, yes, you are going to have a drop cable that's carrying your AC power down to the pump. And then you're going to have some type of drop pipe that's installed in the discharge of the pump. And generally how they set the pump down hole is the wire kind of just follows along. Typically they affix the wire to the drop pipe, and then they lower the pump with the drop pipe, whether it be PVC, roll poly, steel pipe. Typically there's not an install with these types of pumps that have a guide cable or a guide wire that goes down with them, because they are so lightweight. And the drop pipe that is used to install them is more than sufficient to handle the weight and the load of dropping the pump down hole.
Gotcha.
So Joel, let's talk about the wire sizing, if you don't mind, how we select the gauge of wire that we're going to use.
Yeah, Vince, if you don't mind, can you pull up our wire? There we go. Perfect. Yeah, so what you see here is the SQ wire sizing chart, as well as the tank sizing chart. Very typical in our industry to have these types of documents, whether it be for a 4-inch product or a 3-inch product. But the reason we specifically do the SQ wire sizing chart, and we don't go off of a conventional chart, is because with the SQ, typically you can use one wire size smaller than you would on a conventional product. Again, because we're pulling less amps, because we have a permanent magnet 3-phase motor, which is more efficient. So now the installer can actually step down one wire size per horsepower than he would in a conventional unit, which means cost savings. Same thing with our tank sizing chart. It also does not follow a conventional tank sizing chart as you would with a 4-inch product. You can use a smaller tank on the SQ and SQE than you can in the same horsepower of a 4-inch conventional unit. And that's kind of what we're showing here. This is obviously pulled from our IOM manuals that our contractors receive. But those are two big features. So you can use a smaller wire, less cost, and you can also use a smaller tank per the same horsepower that you would with a conventional unit. So you have cost savings on both of those.
Okay, so help me understand the tank part of this equation, because are you saying that once the water is transferred out of the well, you're talking about the size of the tank that retains this?
Yeah, so a typical install system on a pressurized system, let's say for a residential home, is going to have a pump, a pressure switch, and then you're going to have a bladder tank up top. So, and that tank it's for, in conventional systems, that tank is to minimize the starting and stopping of the pump. Because on a standard 4-inch motor, you have 10 starts and stops per the hour. That's what they're rated at. And meaning if you go over that number, now you're creating additional heat in the motor. So potentially having a shorter life on that pump and motor unit. So conventional units, they kind of size that tank per the flow rate for that particular application to match up with that 10 start stops per the hour. One other thing the well tank does is also remediate water hammer in the system.
Right.
So when we have a pump turn on, your pipes aren't banging around in the home, and we're not being hard on the pump, we're not being hard on the tank, not being hard on the pipe work in the home itself. So that's really the two main functions that the tank serves.
I see.
Now, the
Interesting.
4-inch
But as a result of the SQE, the required size is diminished because of the efficiency of the whole unit itself. So you don't need
It's
as
really
much.
because of the soft start function, Vince, allows us to allow the pump to cycle a little bit more without building up that heat. So it's the technology in the motor that allows us to use the smaller tank. People who put in traditional systems might look at it and not understand when we say we can use a smaller tank, because they have been taught there for years and years that how important tank sizing was to protect the 4-inch pump. And with all the protections that are built into the SQ and the soft start, we don't need that tank to protect us, right? To protect our pump,
Right.
Because the pump is designed to work with the smaller tank. So it is a little bit of a challenge for us to teach our contractors and the guys that we're presenting this product to and helping, is to get them to understand it's okay to use that smaller tank. You're not going to damage the system. You're not going to have a shortened life by doing that.
Well, and this is why I do this kind of thing, because and if you follow me on Lunch and Learn with Vince, I've said it a million times, but it's the truth. The whole purpose of what I'm doing here is to encapsulate important information that could be utilized a year, 5 years, 10 years from now. When I'm long gone, somebody may encounter this kind of a situation and go, what's going on here? And they can look at the technology, look at the information, and understand that this is why a smaller tank was utilized, or how to save the well with a smaller diameter. I mean, it's genius. It actually is a great idea. It's a wonderful way to repurpose an old well. Let me ask you this: how long would one of these SQ or SQE last down the hole? How long anticipated length of time?
It's an interesting question. I think here a couple months ago, the VP of our company sent all of us a picture, and one of the original demo units from 1999 had just come out of the hole. A lot of factors come into play there: water quality, reliability on the power grid that particular unit is on. But I think it's a fair statement and I think Alan will agree with me. Usually on a conventional system, you're talking maybe 7 to 10 years. And I think with an SQ, you'd get 10 plus, considering, everything is within the limitations required, by the IOM manual. I would say it's a 10-year plus pump. And I would say that's pretty good in our industry these days. You go back 50 years and some guys are still pulling out pumps that, from the mid 70s. But I think the average nowadays is 5 to 7. And I think we're a 10-year plus pump.
I think that's wonderful. That's a good investment in a reliable product. So that's awesome. Let me ask you this. I don't want to put you on the spot, but where are you going to be next? What show will you be attending to show off these products?
Yeah, so at the end of the month, we're actually at the South Atlantic Well Drillers Jubilee in Myrtle Beach, South Carolina.
That'd be fun.
Very historical show. Alan, I can't remember the years running, but I know it's 50 plus.
It's been around a long time.
Yeah, and it pretty much encompasses the entire Southeast. So that's kind of our next opportunity to display our products. We'll have our trailer there. So, Alan, I can't remember the sizes. You can probably speak to the trailer a little bit better, but it's a very nice educational tool that we possess.
Yeah, it's about a I don't know, 16 or 18-foot box trailer, and we've got working demos of the SQ, the SQE pump in there, as well as our solar pumping technology and some of our traditional 4-inch and some booster products. So we've got a number of working demos in there. We've actually put water into it. We run the products. We can show how they're set up, how they're programmed for the electronic controls, things like that. So it's a fantastic place to come, meet the Grundfos folks, see the products. Joel and I are both also going to be doing CEU classes at that show. So come see us if you're in the Myrtle Beach area the last weekend in July.
So tell me this: how do people get in touch with you guys, Joel?
I can be reached via email at Rackley, Rackley at grundfos.com.
Alan, same thing?
Yeah, same thing. It's a Bixler at grundfos.com.
And we'll have that information in the below the YouTube video. Feel free to get in touch with these guys. Guys, I have to tell you, it's been delightful getting to know you a little bit and hearing a little bit more about the pumps that you take care of for handle for people, the SQ and the SQE. You mentioned solar pumps as well, and that is my entree to our next lunch and learn, because I don't want to go into the weeds with that.
Sure.
Now I just want to leave that one there, but I am fascinated with the concept of using solar power to run a pump.
I'll give you just a little tease on that,
Please,
Vince.
please do.
In 1999, we launched the SQ and the SQE, and shortly after that, in 2001, we took that same 3-inch motor technology, modified it a little bit, and that became our solar pump platform for a number of years. It's expanded since then with some other product line, but it started out with the 3-inch SQ design, modified somewhat to work on DC power directly from a solar array. So exciting, and I think you'll have a great lunch and learn on solar pumps.
Yeah, we need to talk about that one next. We need to get in touch with our people. I'll have my people talk to your people, and we'll definitely
do that.
Now, this actually sounded like it was planned, but that was not planned. I mean, I was just really truly asking you about it because I personally I'm fascinated with the idea of solar power. How clean can you get if we can ever really perfect it and really make it efficient? And I love seeing that.
Yeah, the biggest issue is how do you store it?
Yeah. But again, I want to thank you guys. It really was a pleasure. Grundfos Pumps, they're the biggest pump manufacturer in the world, and produce some great pumps and some great people like Joel and Alan. Again, thank you for joining me on Lunch and Learn with Vince.
Thanks, Vince.
Thank you, Vince. Appreciate it.
If you like what you see, hit like and follow, and you know what to do. Come on, bye.